This video is an introduction to the feature-based meshing available from the mesh control in HyperMesh. As you may know, the mesh control is a way to ease and automate and streamline the meshing process inside HyperMesh. You can basically create model or local mesh control really easily, define your meshing parameters, assign the mesh control to a specific area or on the full assembly, the full model, and run the meshing process. This process is saved into the HM file and could be also export and re-import into another project. So let's take an example in order to give you a proper introduction to the feature-based meshing available from there in the surface mesh of the mesh control browser. This example is the following: one basic part with some details, some features, lines, holes, fillets, and fixed point. If you try to mesh it with the general 2D mesh algorithm of HyperMesh, basically, it's quite small. Basically, as you could see, this algorithm should respect the topology of the geometry. Where you have a line, a fixed point, you will get a node. Okay? So it is maybe not the best way to generate a mesh on this part. Let's delete everything. Another way that you may know is to use the batch mesher techniques, which basically allow you to automatically and interactively do some geometry cleanup. As you could see, the geometry has been modified, some edges are now suppressed, and the batch mesher will also give you a nice 2D mesh that can be filled with tetra element later. Okay, so this is a second way. Let me do some undo. And the third way is to use the feature-based meshing from the mesh control. So this technology is actually coming from SimLab, another preprocessor of Altair, and use a completely different techniques, philosophy of meshing. Let me show you that. Let's create a basic body feature mesh control. As you could see, this mesh control is waiting for a selection of entity. So let's ask to mesh this part and some meshing parameter, for instance, 5mm element size. And let's just do a right click on the feature folder and mesh it. Automatically, the part is meshed. And if we zoom in a little bit at the same location as previously, as you could see, the feature mesh control is not constrained to the topology. Actually, the feature mesh control do not see the topology at all. So inside this meshing algorithm, automatically, the algorithm can handle the geometry cleanup. So there is no geometry cleanup. The geometry is still the same. It is not impacted by the mesher, but the mesher is able to give you a proper and nice mesh as it is requested and defined in your meshing parameter. Okay, let's have a look. Let's focus on some options that we have on the feature folder. Let's go back to the geometry. Let me deselect, delete every element. And let's, for instance, increase a little bit the minimum element size to 1.5. Let's rerun the meshing. And as you could see now, let's hide the geometry. As you could see, we don't have anymore any element less than 1.5mm. So automatically, all the geometry detail less than this value will be collapsed. Okay. Another option is the maximum angle per element and the minimum element size. So with these two parameters, you can basically control how thin the mesh is on some curvature area. If I reduce a little bit this value and run again the mesh, where you have some curvature, such as this hole, you will get more element with small element value there. Okay. Another great capacity of the feature mesh control, it is basically to follow a specific mesh pattern on some features. For instance, you can define fillet mesh control. Let me display the geometry. Select some surfaces manually, and it could be also automated, of course. So let me select this fillet and ask to have 3 elements on the curvature. Let's do a right click on the feature folder and let's create a washer mesh control. Select some lines, these 2 lines here and these 2 there, and let's ask to have 1 washer around those lines. And let's remesh it. Okay. As you could see, automatically we could get this kind of nice mesh pattern on the fillet without, or this kind of washer, without doing any geometry cleanup or modification, directly on the mesh. Okay, let me delete every element and let me talk about one specific topic. What if you would like to have a conformal mesh between 2 components? Let's create a new comp and let's fill the hole on the top with a patch. And let's organize this surface on my second component, like that. So inside HyperMesh, you have 2 components correctly connected to each other in terms of the topology. Okay? If you mesh it with a general 2D approach, as you have a correct topology, connected topology between the 2 components, you can have a perfectly connected mesh on those 2 components. But as I told you earlier, the feature mesh control, the SimLab algorithm, do not use the topology. So if I, for instance, create another body mesh control and ask to mesh this second component with, for instance, an element size of 3 mm and run the mesh, as a result, what you will get is a non-conformal, not connected mesh, as you could see now. So if you're in that case and would like to have a connected mesh between several components or parts, what you have to do is basically, let me delete every element, is basically to organize all your surfaces or solid into one comp, like that. In the first body mesh control, define the one settings of meshing parameter. And let me delete this one. Or create a local mesh control, for instance, a face mesh control on some surfaces, this one, with a specific mesh element size. And this way, you could get what you want. Another thing to keep in mind is if you would like to combine the feature mesh control coming from SimLab and other algorithm coming from HyperMesh, SizeNBia, QOptimize, etc., etc. In that case, it is not a good practice actually to combine those 2 meshing techniques, because as we saw, SimLab algorithm is not based on the topology. So what you could get if you use the two, you could get a non-connected mesh. Let me show you that. Let's delete or actually disable this mesh control, and let's keep only the face mesh control with the 3 mm element size here on the surface. And let's create a size NBA on the component here with an element size of 5, and let's ask for 3 elements. And let me add in the feature mesh control some other surfaces that one. Okay, so we've got one model mesh control that will use HyperMesh algorithm, the size NBA, on this component, and we ask for a 5 mm element size. And we have one face mesh control. It is a feature mesh control coming from SimLab, and it is assigned to these 5 surfaces. If we run that, what you can get is on the top, the mesh looks like to be correctly connected. No issue, no problem. But let's have a look here at the bottom. It looks okay, but if you pay attention, as you could see, we don't have a connected mesh on this location. Why? Because this surface has been meshed with HyperMesh, and therefore every fixed point should remains. But the top surface here has been meshed with SimLab, and SimLab doesn't care of this fixed point. So this fixed point is completely collapsed in SimLab, but not in HyperMesh. So that's why it is not a good practice to combine the two different mesh control, feature mesh control and HyperMesh mesh control.